Hello, welcome to this lecture. In this lecture, we'll show that if you have two curves in R3 and they have the same curvature and torsion, so then there exists an isometry of R3 which takes one curve to another curve. Okay? All right, so let me state the theorem. So let us take two unit speed curve in R3. So let gamma s and gamma tilde s be to unit speed curve in R3. Okay, so with same curvature Ks greater than 0 and the same torsion. Okay, so then the claim is so then so there exists an isometry M, which is also sometimes called rigid motion, of R3 such that this M of gamma s is equal to gamma tilde s for all s. Okay, and further, so if so this k and this tau are smooth real valued functions, okay, so with k is a positive function, means k of s is greater than 0 for all s. So then, so there is a curve in R3. So there is a unit speed curve gamma in R3 whose curvature is given by this function k, and torsion is tau. Okay. Okay, so how do you prove this thing? All right. So so suppose you have these two curves in R3. So this is my curve gamma, and gamma is 0. It is a point on this curve. And you have another curve, which is my gamma tilde. And this is my point, gamma tilde is not. Okay. So now, so what you can do, so you can apply a translation to take this gamma tilde S naught to gamma S naught. So apply a translation. So T is a translation, which is an isometry, such that T of gamma tilde S naught is equal to gamma S naught. Okay, all right. So therefore, without loss of generality, I can assume that gamma S naught is equal to gamma tilde S naught. Okay, so assume. So without loss of generality, so assume gamma S naught is equal to gamma tilde S naught. Okay. So now these two curves are given, which is passing through the same point, and for both these curves, curvature function and torsion functions are same. Okay. So now let T and B be, so this T and B, so be the tangent vectors, normal vectors, and binormal vectors of the curve gamma, and respectively T tilde, N tilde, B tilde be the unit tangent vectors, unit tangent vector, unit normal vector, and unit binormal vector to the curve gamma, and respectively this T tilde, N tilde, B tilde, so they are also this tangent vector, normal vector, binormal vector to the curve gamma tilde. Okay. So now if I draw a picture, so this is my, say, curve gamma, and this is my point gamma S naught. Okay, and here, so you have this strad, something like this. So this is tangent vector, this normal, and say this is binormal. Okay, so you have this thing, and for this curve gamma tilde also you have so another trad T tilde, N tilde, B tilde. Okay, so so this T and B, so this is an orthonormal basis for R3. And also, maybe I'll just write down here T of S naught, meaning tangent vector, normal vector, and binormal vector at the point gamma S naught. And we have another orthonormal basis of R3. Okay, so I'll get an orthogonal transformation which will take one basis to another basis. So there exists an orthogonal matrix A such that A takes one basis 2 to another basis. Okay. All right. Okay. So so again, so I'll work with A of gamma tilde. So A is an isometric of this R3. Okay. And so this A, it takes T tilde to T. A takes N tilde to N, and A takes B tilde to your D. Okay. So this isometry, it takes this orthonormal basis to another orthonormal basis. Okay. So again, so without loss of generality, so what I can assume, so without loss of generality, so assume this T tilde S naught is equal to Ts naught, N tilde S naught is equal to Ns naught, and P tilde S naught is equal to Bs naught. Okay, so let us assume this thing, and yeah, also we have this gamma tilde S naught is equal to gamma S naught. Okay, so now we have two curves. Okay, and at the point S naught, these three vectors, three unit vectors, tangent vectors, normal vectors, and binormal vectors, so they are same. All right. Okay. All right. So again, let me draw this picture here. So I have something like this. So here I have this this tangent vector. Yeah. So it is difficult to draw a picture. Let me try. So suppose this is one of my curve here, and another curve is something like this. So for both the curves, so this will be my tangent vector, and normal vector will be also same, and binormal vector will be also same. And this is my point gamma S naught. Okay. So this is gamma, and this is gamma tilde S. Let us take this point here, and let us take gamma S, this point here. So now at this point, so again you have this normal vector Ts, sorry, tangent vector Ts. You have this normal vector and this binormal vector. Okay. And similarly for this gamma tilde S also, you have the same thing. Okay, so you have the same thing. So next, what I'll show that this Ts is equal to T tilde S, Ns is equal to N tilde S, and Bs is equal to B tilde S. Okay, so in order to do that thing, so let us take this function. So we have to apply a trick. So let Fs is equal to this dot product, T tilde S dot product with Ts, plus n tilde s dot product with an s plus b tilde s dot product with bs. Okay. Uh, yeah. So f of s naught. Okay. So f of s naught. So t of s naught is equal to t tilde s naught. So the first term it will be equal to your 1. Second term will be also equal to 1. The third one also will be equal to 1. So this is equal to 3. Okay. So now the claim is the following. This f of s. So this will be uh, equal to 3 for all s. Okay. All right. So so now note that. So if I take this dot product, so this is always less than equals to 1. Okay. So because norm of these two things, this will be ts. So norm of these two vectors are equal to 1. Okay. So a dot b is equal to ab cos theta. Okay. So and a and b are equal to 1. So cos theta is always less than equals to 1. So therefore we have this thing, this inequality. And here this equality occurs if and only if this t s is equal to t tilde s. Okay. And the same is true for same is uh, same are true for this n s dot n tilde s and bs dot b tilde s. Okay. So therefore, so what we have, so f of s is always less than equals to 3. Okay. So f of s is always less than equals to 3, and equality holds if and only if uh, ts equal to t tilde s, ns equal to n tilde s, and bs equal to b tilde s for all s. Okay. All right. Fine. So okay. So now we have to prove that this f it is a constant function. Okay. So now what we do? So we just take the derivative. So df ts. So this will be equal to, so t tilde dot t plus t tilde dot t dot, or yeah, and then you have this thing. Okay, so you have this thing, and now use this Frenet Serret equations. Okay, so if you put this thing here, so it will be equal to uh, k n tilde dot product with t plus minus k t tilde plus tau b tilde dot product with n plus minus tau n tilde dot product with b plus T tilde dot product with Kn plus N tilde dot product with minus K T plus tau B plus B dot product with minus tau N. So we'll get this thing, and so this will be equal to your 0. Okay, so this shows that f is a constant function and f of s naught equal to 3. So this implies that f of s is equal to 3 for all s. Okay, so we have this thing here. So using this, so how do you show that this gamma s is equal to gamma tilde s? Okay. Uh, okay, so from here, so what we are getting, so this t tilde s is equal to ts, n tilde s is equal to ns, and b tilde s is equal to ps. And so this will imply that gamma tilde dot s is equal to gamma dot s. So this means that uh, gamma tilde minus gamma s. So this curve, if I take, so this is equal to constant. Okay, and we know that gamma tilde s naught is equal to gamma s naught. So gamma tilde minus gamma s naught. So this is equal to gamma tilde s naught minus gamma s naught. So this is equal to 0. So this tells that gamma tilde s is equal to gamma s for all s. Okay. So we have this thing now. So therefore, uh, so these two curves, gamma and gamma tilde, so they are equal. Okay. So now for the second part, okay. Yeah. So so we have to apply the theory of ordinary differential equations. So to show second part, uh, so it follows that it follows from the theory of ordinary differential equation. So that, so I'll just write this uh, this Frenet-Serret formulas, these equations. Okay. So if I take this t dot equal to kn, n dot equal to minus kt plus tb, b dot is equal to minus tn. Okay, so this k and t, so these are my given functions, and these are my differential equations. Okay, so this this set of differential equations, so they have a unique solution. Solution ts ns ps, and some initial condition it is given, so such that t of s naught is equal to this standard unit vector, n of s naught is equal to this, and p of s naught is equal to this unit vector. Okay, so we have this thing. So now note that, so from this above differential equations, so we'll get a skew symmetric matrix. So 0 k 0 minus k 0 t 0 minus t 0. Okay. Uh, so we'll get this skew symmetric matrix from uh, this differential equation. Okay. So this is skew symmetric. Okay. So because this is skew symmetric matrix, okay, so then what you can show that, so uh, so as this matrix is skew symmetric, so the vectors, so the solution obtained, so the vectors ts ns ps, okay, so this is an orthonormal set of vectors, okay, uh, are orthonormal for all values of s. Okay, all right. So we have this two functions k and this tau. So sorry, this should be tau here. Yeah. So we have these two functions k and tau. K is the curvature function, tau is the torsion function. Okay, and I got this differential equation. You solve this differential equation. Okay, so we'll get three solutions. This Ts, Ns, Ps. So now we have to obtain a curve gamma, so whose tangent vector will be T, normal vector will be N, and binormal vector will be P. Okay, so how to find that curvature? That curve. So let us define. So gamma of S to be this following integration S naught to S T of U du. Okay. So then, so this gamma is a curve in R3. And what is my gamma dot S? So this is equal to T of S. Okay. So T, it is a unit vector. So T unit vector. So this will imply that, so gamma is a unit speed curve. Okay. And this T dot is equal to Kn. Okay. So this will imply that K is the curvature of N. Okay. And similarly, so using this differential equations, so you can show that this tau is the torsion of the curve gamma. Okay, so yeah, so therefore we have this result. Okay, so we'll stop here.